Hello everyone and welcome to this tutorial. We are designing the DA50 RG aircraft using CATIA V5. I'm using the 2017 version, but you can use any that you have. Go to YouTube and search this video of the DA50 RG workaround and get an idea of the kind of surfaces that we are trying to create using Gsd Catia. Now, the first step when it comes to aircraft design is the wing design. And the first step in wing design is the airfoil selection. In this case, we are doing reverse design. So what you can do is search the technical specifications of the aircraft, and using these performance details here, you can reverse design and search the most appropriate NACA airfoil to use in this case. I've gone ahead and done that. So go to airfoiltools.com. And we're going to search for NACA 64 to 415. NACA 64, open bracket, 2, close the bracket, dash, 415. And select this first one here. Now we're going to send this to Airfoil Plotter. And the most important thing that we need in this case is the chord measurements right here. I've gone ahead and made this hand drawing showing you the kind of measurements that we are going to be using to create this cross-section wing. So this is the half span, and you can see here I have the root chord, the mid chord, and then the tip chord as well as the winglet chord. And we're going to go ahead and enter that, starting with the root chord, which is 1863. We're going to leave thickness at 100%, and we're going to include a pitch of 2 degrees. This is to ensure that when we are in steady and level flight, that our wing is still generating some lift. Plot. And what we need is this CSV file of coordinates. What I have done, I have created this folder right here on my desktop, and I've configured my downloads to go there, but you don't have to do that. You can just download and copy and paste them later in a folder where you're going to access them easily. So let's save this file of coordinates. For the mid airfoil, we have a chord of 1262. The other parameters remain. And plot. Save the CSV file of coordinates. Tip chord, we have 901. Parameters still remain. And plot. Finally, we have the winglet airfoil, which has a chord of 375. We are going to reduce the thickness by 50%. We are going to leave the pitch as it is, and we are also going to plot a mirror image. And I'm going to explain this later on, but we are plotting this airfoil section on the X and Y plane, contrary to the 3 other ones that we are plotting on the ZX plane in CATIA. Plot and save the CSV file of coordinates. So now I have these 4 airfoil sections right here, and I'm going to rename them. This is the root airfoil. We have the mid airfoil. The tip airfoil. And finally, we have the winglet airfoil. Now, to plot these sections in CATIA, we are going to need the GSD point spline Excel file for CATIA. You can go to CATIA and right-click, select Open File Location, type the first 3 words GSD, and you're going to locate this Excel file and open it. Now yours might have some stuff in between. It's okay, I just deleted mine by mistake, but you actually just need these 2 right here, so you can clear anything in between. Here is our profile of the wing. As you can see, we have the root chord tapering off to the mid chord, and we also have a winglet. Now, we are going to be plotting our wings span-wise in the y-axis, chord-wise in the x-axis, and the z-axis is going to include the thickness as well as this dihedral angle right here. Now, this is very important because when you're importing your CSV file of coordinates, they come as a two-dimensional x and y coordinates. We are plotting a 3D wing, but every section is a 2D image. So we are going to change these coordinates according to which plane we are plotting our section at. Each of our airfoil section is plotted on the ZX plane. Therefore, those coordinates that we just imported, X and Y, is actually X and Z. And our Y coordinates are a constant value along the span. The root chord is at 0, the mid chord is at an offset distance in the y-axis, and so on and so forth. Now let's go ahead and do it practically so you can be able to understand what I mean. Starting with the root airfoil, we are going to plot each section. So now x is equal to, we are at the origin, is equals to x, y is equals to 0, and z is equal to this y coordinate here. Drag this along the airfoil section up to where you see the camber line start, right here. Repeat the same for the y and z coordinates. Now we are going to copy this. Copy and paste them right here. Paste the values and then cut this and paste it at the end right here. Okay, now go to View, Macros, View Macros, select Main, Run, and select 2 for points and splines. Then OK. And now, if you go back to CATIA, you can see that we have plotted this airfoil section right here in our Z and X plane. And all the other one will be following along the Y-axis right here. This is the leading edge, the tail, and we have, this is the bottom surface, and this is the top camber. So let's go ahead and plot the other ones as well. Let's go to the mid airfoil. X is equal to an offset of 406 plus X coordinate. Y is constant at 2091. And Z is equal to an offset of 220 plus this coordinate right here. Let's go ahead and drag that formula along the profile section. Copy. And we're going to paste them here. Paste the values. Just confirm nothing is overlapping and run the macros. Select 2 for points and splines and OK. So now there we have our mid chord. Let's plot the tip chord. Tip airfoil. X is equal to, again, an offset of 406 plus the X coordinate. Y is constant at 6703 and Z is equal to 705 plus this coordinate. Copy, paste them here, paste the values and check if we have nothing overlapping in the cells. Run the main and select 2 4 points and splines, and now we have our third section right here. Now let's plot the winglet section. And x is equal to 1080 plus the x coordinate. Enter. Y is equals to 6888 plus the y coordinate, and z is equal to 1110, and it's constant. Now let's copy this and paste it in the CATIA file. Confirm nothing is overlapping, then run the macros, select 2 4 points and splines, and select OK. Now if you go to CATIA, you can see that we have our airfoil section right here, winglet section. And what I was trying to explain earlier, you can see this is the XY plane, but this ZX. But this top camber right here needs to join with the top camber on that side. And the bottom camber needs to join with this bottom profile. But if we did not plot the mirror image, this would not happen. But we are going also to see that when we are plotting the lofts, the surfaces. So let's go ahead and do that. You can go to Insert, Surfaces, and select Multi-Section Surfaces. Or if you see this icon right here on your desktop, on your workspace, then select it. Now, the first thing when you import your airfoil sections is to check if they are actually closed at the end. And in this case, they are. Now, if I just select these 3 airfoils, let's hide the points so it's easier to select. If I just select these 3 airfoils and preview, you can see that it's trying to connect 3 of them using this curvature right here, but we don't need that, because if you look at this image right here of the wing, we have that straight taper that goes from the root to the mid chord, and then it goes again straight to the tip chord. So there's many ways to do this. In this case, I'm going to just build it section by section, but you can use guides and create these straight lines connecting here and then again here, and do the same for the bottom side. But in this case, I'm just going to select this spline and this spline, preview. You can see that it's tapering off straight, and then again from this spline to this spline right here. And now you can see that we have that kind of straight taper that we were looking for earlier. So let's go ahead and create the winglet. And in this case, we are going to need guides. I don't know if you can get a picture of the winglet section so that you get the idea of what we need to do. So DA50 RG winglet. Let's go to images, scroll down, and I think this one will do. So if you look at this, we have plotted these sections on the ZX plane, and now we need to plot this section, which is actually in the XY plane. And you can see that this endpoint right here is kind of just curving upwards, but on the front side, we have this kind of offset, which is going rearwards and also kind of upwards before we connect straight up. So this is exactly what we need to do in CATIA. So let's create the first points. I think I'm going to change the color of these sections for you to be able to see them more clearly. Let's select maybe a gray color, dark yellow. This looks good. This way you'll be able to see the lines when we create them. I'm also going to show my points again. Show all points. And the first thing I'm going to do is to create a line that offsets from this point. So select line, point and direction as the type. Select this end point, and the direction is the Y component. And then starting from 0 up to 55 millimeters. Let me zoom in here so you can see what we've created. Okay, and I'm going to create another line that starts from the end point of this line to the last extreme point of the winglet section. Select line. You can go to insert wireframe line. Now the line type is point to point. Now select this end point and then zoom in and select the other end point, extremity of the winglet section. Select OK. Now we're going to create a 3D curve. You can go to insert wireframe corner. I'm going to select it from here and select these two lines. And because this line was 55 millimeters, I'm going to try 50 millimeters as my radius. So 50, and I'm also going to check these two boxes for trimming the elements. That looks good, so okay. All right, now let's create the front side. Now I need to create a point that is kind of offset from this extreme point here up to almost the midpoint, and it's also going upwards a little bit. So for you, the easiest method I could say is click on this extreme point and measure the item to see the coordinates. So you can see the X is 406. I need it to offset to almost midpoint, so I'm going to try 800 millimeters. The Y is 6703. We are going to add 55, and that is going to come to 6758. The Z is at 705, and we're going to maybe try 750, okay? So create a point by coordinates. X is 800, Y is 6758, and Z is 750. Preview, there we have it, and okay. Now we're going to create a line, point to point, starting from the point that we just created to this extreme point right there. And the next, we're going to create another line, again from the point, and it's going up to the extreme point of the winglet section right there. Now let's create another corner. Select both of the lines, trim both elements, and now these lines are kind of longer, so I can try 150 as my radius, and I think that looks good. Now let's go ahead and hide tools, hide all points. And now again, I'm going to create another section using multi-section surfaces. Select spline 1, spline 2, and then these two corners as our guides. Okay. Oops, let me remove this one. Select on the guide section, you're going to select the two corners. Preview. I'm still using ratio as my coupling method. And okay. Now tools, hide all curves. And here we have our winglet section. Our winglet section as well as the wing. I'm also going to hide all planes. And as you can see, we have half the wing. Now I'm going to join all three. I've selected all three. And if you preview and if you did everything correctly, you should just have two boundaries at the end which are indicated with the green lines. To complete the wing, all you need to do is to mirror this one in the ZX plane. So operations, you can go insert operations and select symmetry. We are going to select our join one and the ZX plane is our reference. And okay. Again, insert operations join, and I'm going to join symmetry 1 with join 1. Preview. Again, if this one is done correctly, you should just have two boundaries at every extreme end highlighted by the green color. Now we have one wing. Let's change the color again, the material, to make it more visible. In this case, I'm going to use this color. There we have our wing section. Actually, let's try a different color that is more visible. Okay, I think I'm going to go with this one just for visibility purposes. And here we have our wing. And now we can go ahead and convert this wing to a solid model that can be used for structural analysis as well as finite element analysis, fluid flow, you know. And the way to do that, you can go start, mechanical design, part design, and insert surface-based features and choose close surface. Select OK and select this join to and OK. Now if you hide your surface right here, you're left with a solid model that can be used for analysis. You can try different views here to visualize the wing, and now you can compare this with the images that we had before. Here is our top section of the wing, and you can look at the side where you are able to visualize the winglet section right here. Okay, and finally you can be able to visualize the dihedral angle right here from the images that we had before. All right, in our next section, we are going to be designing the nose, and then in the other part, the body, the tail, the vertical and horizontal stabilizers, and at the very end, we're going to design the propeller. I hope you stick around and see you again.